units are so that you can substitute correctly. So very quickly, N is the symbol for amount. So think of the N in amount. What is the unit for amount? If you want to type on the chat or if you want to talk, you're welcome to. Mole, correct. Okay. Mole with an E is the full thing. Mole without an E is just the abbreviation. Like gram is if you write out GRAM, or G is the abbreviation. Then we have this, which is a small m, which is mass. What is the unit for mass? Gram. Great. And then we have this big M, which is molar mass, or the mass of 1 mole. And what is the unit for molar mass? So it's gram per mole. So you can either say G MOL to the -1. Okay, you were correct there, Louis. You just had the G at the other end, but it's fine. Or you can, it's not the most scientific way of writing it, but you can say G/mole. So it's gram over mole is a gram per mole. So these in orange are the same thing. Then with the other formula, you've got C, and C is in concentration. Now you do have to work with 2 different types of concentration, the official concentration as well as percent concentration. And we're going to do both of those here. And so the official concentration unit is what? Anyone to have a guess or know it? It's mole per liter. So ml minus 1, or you could say mole/liter. Okay, so if you get given units in milliliters, you have to change to liters because the units for concentration are moles per liter. This again is amount. So you'll notice trying to swap from one equation to the other, you work through N. Because once you've worked out N in one equation, you can use that for the other equation. And then the final one we work with is volume, and that is given in the units of liters. So it's really important that you know what those things stand for. So when you are given a whole lot of figures, so say you're given 0.01 etc. mole per liter, you know straight away, because the unit is mole per liter, it must be concentration. So it's really important, spend some time making flashcards. There are Quizlets in the workbook to make you remember this. Okay, so now that we've got that, let's now go down and do it. And you can see I actually based this off the one of the teacher marked assignments. So this should not be ammonia. The exact concentration of 3.2% muriatic acid. Muriatic acid is just the common name for hydrochloric acid. So you sometimes will see it in the shops as muriatic acid, or you might see it as hydrochloric acid. So you normally buy hydrochloric acid in, say, Bunnings or whatever for removing any mortar of bricks if you want to clean your bricks or swimming pools or so on. And so what the first section is going to be that you have to work on is steps 1 and 2. And then in the lab, you do steps 3 and 4 and 5. And then at home, you fill up all the report and you do also step 6. So let's go through it. So if you look over here, I've got an acid, which I need to then react with a base. And I'm going to use sodium hydroxide. Now, sodium hydroxide, remember, is not what we call a primary standard. So I can't just take sodium hydroxide out of a bottle, weigh it out and make a solution, because sodium hydroxide reacts very rapidly with water in the air, water vapor, with carbon dioxide in the air. So it's never an exact pure substance. So I need to actually, what we say, standardize my sodium hydroxide by reacting it with something that's very stable. And so I'm going to react it with oxalic acid. So that's that one over there. So you don't do this in the lab. If you were working in the lab, you would weigh out an exact amount of oxalic acid and make it up into a volumetric flask up to the meniscus over here, where it's exactly 250 milliliters. So this is what we're going to be doing here. We're first going to be weighing out the oxalic acid. And what I've said is you've weighed out 1.6 grams of oxalic acid, and it actually comes as a dihydrate. Okay. Now you'll notice in the assessment tasks, we always give you the molar mass. So as long as you can recognize that big M as being molar mass, then you should be fine, or the units at least, grams per mole. So in the teacher marked assignments, we actually ask you to calculate molar masses because we want you to practice for level 3 as well, because you need to be able to know how to do it for level 3. But here you will be given the molar masses. So the first thing, somebody's got the mic on, which is fine, but it's just going to pick up in the recording. That's all. So the first thing you can always write is your molar mass. And I'm just going to say OA for oxalic acid. Always try and say what you're working with, because when you swap from one substance to the other, you must be very clear which substance you're working with. So OA for oxalic acid, we know is 126.0 grams per mole. So we always know that. Now you look at what else are we given. So we need to calculate the amount. And we are also given, I'll just go to another color, we are also given a number over there. So hopefully, from what we said before, amount we will know is N. So N for oxalic acid is what we need to calculate. And hopefully when you see that G, you will know this is mass. So we know the mass of oxalic acid is 1.6 grams. Okay, now notice I said 1.6, but I added the 0 because for excellence, the significant figures are important. So always try and keep at least 3 significant figures during your working. Now, if you've got your big M, your N, your little m, you go back to the top of the, or wherever it is, and you go, which of use the one on the left-hand side. And so N is equal to small m over big M. I'll 1.60 grams divided by 6.0 grams per mole. And that will give me an answer if I get my calculator out. Let's sort of keep it on this side. So if you just go 1.6, now obviously the calculator doesn't care whether you've got significant figures or not. So I'm just going to not put in the 0, but divide it by 126 equals. Now notice it gives you a whole lot of numbers. So write at least 3 of them down, but keep all the figures in your calculator. So my answer is 0.012698, etc. So I'll just go 127 because the 9 being bigger than 4, it's 5 and above, the 6 next to it changes to a 7. So is equal to 0.0127 mole. And again, check your units that they cancel out. And if they cancel out correctly, leaving you with the correct unit, you know you haven't made a mistake like you haven't put 126 at the top and 1.60 at the bottom. So putting in your units always helps, keeps you on track and stops you from making silly mistakes, because it's very easy to muddle things up, transcribe numbers, put things in the wrong place. It's very easy. Okay, so now that you've got that, you now need to calculate the concentration. So you need the concentration of oxalic acid. So that is what you've got to calculate. So again, you can refer back to the top, what equation to use. And remember, we had C is equal to N divided by V. So this 1.60 gram, ooh, this is wrong. I forgot to change this. This is 1.6, that's carbon, that should be oxalic acid. Okay, so calculate the concentration when you've weighed it out. So we've done it all over there. So we know our N is this much. So we know that one. We know V because when we look at V, we are given this unit. Now, milliliters is a unit of volume, but remember we have to change this to liters. So our V is 250 milliliters, but we change it to liters. And the easiest way is go multiply by 10 to the minus 3. So it's 250.0 times 10 to the minus 3 liters. So now we just put in the equation. Always follow a method. Write in C is equal to N over V. Then substitute 0.0127, which we got from there, but you keep all the figures in your calculator, divided by 250.0 times 10 to the minus 3. And that is now liters, that is mole. And so if I use my calculator, I've kept all those figures in there, divided by 250 exponential 3 minus equals. And so you can see I've got an answer of 0.05079. Again, the 9 changes the 7 up to an 8. So that is 0.05079, 0.0508. And the units would be mole per liter. Whenever you've finished a calculation, always ask yourself 3 things. Have I put in my units? Have I given my answer to the correct number of significant figures? So there and there. You were told specifically to do it to 3 significant figures, so your answer must be to 3 significant figures for excellence. In the first question, you weren't told. So if you did have more than 3 significant figures, it would be fine still. If you had less than 3 significant figures, it would count against you for excellence, because your measurements that were given to at least 3 significant figures. That one was to 3, this one was to 4. So your final answer should be at least 3 significant figures. Okay. Any questions so far? Okay. Right. Now we're going to be carrying on here, where we actually do a titration. So at the end of last term, we looked at how to do a titration. So we've said, okay, I've got my oxalic acid. Now I'm going to titrate it against the sodium hydroxide. Okay. And so I've got now my HCl in my, oops, okay. I've got my HCl in my burette, and I've got my, whoops, that should be sodium hydroxide. I will go back and I will change all this and I'll resend you the link. So you've got 20 mils of oxalic acid. So you've got your oxalic acid in here. and you've got, because titer always refers to the burette, you've got your NaOH over there. It's always useful to make sure that you know what is what. So what you're going to be working out here is the volume of the sodium hydroxide. And you know you've got to do this because you are already given a volume there of oxalic acid. So you know that the volume of oxalic acid is going to be 20.0 times 10 to the minus 3 liters. So this bit over here is going to be the volume of the other substance, which is sodium hydroxide. So the first step is always to calculate your values. So I'm going to go over here. Now, I always suggest when you're in the lab, as well as over here, use your calculator, but also check, is your answer sensible, by using your brain as well, because you could easily put the wrong thing into your calculator. It's very easy to just dump in the wrong numbers. So, okay, so we've got the 18.2 subtract 0.8 equals, so we've got here 17.4, and that'll be 17.4 milliliters. Then the next one I've got, now we're doing our accurate titrations. So we've got 35. I'm not going to bother putting in the zeros simply because the calculator doesn't care. Subtract 1.7. So you see, I did a mistake, very easy to do. So my brain immediately said, I can't have a rough at 17 and my first result at 33. So I read that value when I had that. It's very easy to make those mistakes. So always engage your brain to make sure you are not doing a silly thing. So that's 16.8. Back to the calculator again. 18.6 subtract 1.7 equals 16.9. So in the lab, you would be doing these titrations until you get 3 reasonable ones. So let's see if we've got this one, 35.7, subtract 18.6 equals 17.1. Now, can you see 17.1 is okay within there, but because you should have within 0.2 milliliters. That's the sort of the maximum, then it starts getting too inaccurate. So you could take those two, but then you can't take that one. Or you could take those two, but you can't then take that one. And then finally, so that's why we had to do another one, because we don't have 3 good results, or 3 results within 0.2 milliliters. So now we go 18.9, subtract 2.2, and that is 16.7. So I'm going to say, okay, I'm not going to do another titration. I am going to be using 3 results that are within 0.2. So I can use that one, I can use that one, and I can use that one. So when I want to calculate the average titer, then so my VNaOH is equal to 16.8 plus 16.9 plus 16.7 divided by 3. And this is just very easy. Hopefully you can do it in your head. It's 16.8 milliliters, or 16.8 times 10 to the minus 3 liters. Any questions so far? All good? Okay, so this, as I say, you'll be given exactly the same sort of thing in the first part of the assessment. You're going to be given titration results. You've got to calculate. You've got to do your average. And in the assessment task, there won't be these silly errors. So, like HCl when it should be sodium hydroxide. It has been double and triple checked. Okay, whereas this one I just actually threw together yesterday for today's lesson. Now here we've got to calculate the amount of oxalic acid. Okay, so I've specifically said use the concentration you calculated previously. So what was that concentration? You go back and you look and you go, right, my concentration was 0.0508 moles per liter. So I'm going to put this in straight away. My C for oxalic acid is 0.0508 mole per liter minus 1. Okay. Okay. Right. So that's the C. Now, again, go to the top, work out what equation you're going to be using. And the one will be C is equal to N over V because it's got C in it and you've got to calculate C. So you know you've got to choose that one. You are also told to calculate the amount in moles. So that is what you've got to calculate, which is another reason why you choose this one. And now you are given a volume. So always look at the question and you go milliliters. Milliliters is the unit for a volume. So that is a volume. But what do I need to do to the 20 milliliters before I can substitute into this equation? Can I just use 20 for volume? Any people wanting to have a go? You're welcome to switch on your mics and chip in if you want to. Just be aware we are recording. Change it to liters. Great. Yep, quite correct. So our volume, I'll just list it over here. Our volume for oxalic acid is going to be 20.0 times 10 to the minus 3 liters. So now we just simply substitute. So C is equal to N over V. Remember, follow that pattern. Don't just put in a mess of numbers, because what's going to happen is it's going to, first of all, confuse you. So you are more likely going to make a silly error. And if you did make an error, if the teacher just simply sees a mass of numbers and is trying to work out what on earth is going on, you are, less likely to do well, particularly if your answer was incorrect. And they go, I don't know what your working is. It's just numbers everywhere. So put in the formula, rearrange the formula for what you want. So in this case, I'm looking for N. So if I'm dividing N by V on this side, I have to multiply by V on the other side. So it's going to be 0.0508 times 20.0 times 10 to the minus 3. And so what I didn't do, I didn't store that previous value, because you should really have kept that 5079 blah, 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 by storing it in here and using your recall memory and so on. But I'm just going to carry on. I'm not going to go back and redo it. So here it's basically 0.0508 times 20 exponential 3 minus is equal to. And you can use your FE button just if you want to make things easier. So it's 1.16 times 10 to the minus 3. 1.016 times 10 to the minus 3. You could have rounded this off to 1.02 times 10 to the minus 3 mole. You weren't told to state exactly, there was nothing here saying give your answer to 3 significant figures, because this is like a partial step to the final thing that we are trying to calculate. Can you see over here? Give your answer to 3 significant figures. This is where you definitely use 3 significant figures. So now we've calculated the amount of moles for oxalic acid, but now we have to do sodium hydroxide. So in order to do that, we use the mole ratio. Where do I find the mole ratio in this question that I've been given here? So in here is the clue to the mole ratio, where I try to swap from one substance to the other. I was working with this, Now I want to swap to that. So what do I look at in this equation to look at the mole, to find the mole ratio? Any guesses? Okay, I look at the numbers in front. If there's no number in front, remember chemists are lazy. So if there's no number, it's 1, because we don't bother writing in ones. If there is a number, like 2, obviously it's 2. So my unknown that I'm looking for is sodium hydroxide, and it's just easier. I mean, there's any ways you can do it, but it's easier to always do the ratio of the unknown to the known. That's just sort of easier to sort out because that means the unknown is at the top, because a ratio is just simply really a division as such. So what you would say is, okay, my mole ratio of acid to base is, and I go, what is it? It's sorry, it's the unknown is the base. Sorry, so I'm going to do the base to acid because I want my unknown first, and the unknown is because it's what I'm calculating is the base. So it's base to acid. So what is the number in front of my base? It's sodium hydroxide. What is the number in front of my oxalic acid? It's 1. So that means I have twice as much twice as much sodium hydroxide as oxalic acid, which is what you'd expect, because I need 2 times the amount of sodium hydroxide to oxalic acid. So to get my N for sodium hydroxide, I take my N for my oxalic acid and I multiply it by 2. So that was the number we had for N for the oxalic acid. So I just simply multiply that by 2. And I go times 2. And so it's 2.032 times 10 to the minus 3. Did I transcribe something incorrectly? Was it 3.2 or 2.3? Yep, no, it's 3.2. Any questions so far in terms of the mole ratio? Nope. Okay. So we're just going to do this last step over here, and then we're going to stop. And we'll just do section B next. I won't be here next week. I'm actually going to be in New Plymouth, so there won't be a lesson next week. Okay, so we've got to calculate the concentration of the sodium hydroxide solution. So now it is CNaOH we are looking for. We do know N for sodium hydroxide because we've just calculated it, 2.032 times 10 to the minus 3. And our volume of our sodium hydroxide, we now have to go all the way back to the top where we calculated it over here. Okay, so make sure you don't muddle up volumes. It is quite a common error where students put the volume of the acid when they're trying to work with a base, or they put the volume of the base when they're trying to work with the acid. That's why it's really important that you're always clear what you are working with, and you're less likely to make mistakes. So it's 16.8 times 10 to the minus 3. And so now we just say, okay, what equation do I use? And hopefully you'll know by now I have to use C is equal to N over V. And N is 2.032 times 10 to the minus 3 and 16.8 times 10 to the minus 3 for, oh, that was volume, that was liters, sorry. Now, did you notice I had a wrong unit there because I was thinking I need to include my units to see that I'm going to come up with the right unit for concentration, which is moles per liter. And now my final answer is If you know your maths, by the way, to make things clear, you could just simply say 2.032 divided by 16.8 because the 10 to the minus, these sort of cancel out. But if you've kept all your figures in the calculator, so you've already got it in there, so now you would just say divided by 16.8 exponential 3 minus equals. And now I've got a long number over there. If I want to get rid of the FE, so it's now 0.1209. So what do I do to the 0 to get 3 significant figures? What would my final answer be? Is it going to be 0.120 moles per liter? Or I have to round. Okay, so the 9 makes the 0 in front of it go up by 1. So my final answer is 0.121 moles per liter. Oops. And remember what I said, whenever you do calculations, you go, do I have a unit? Do I have 3 significant figures, particularly when I'm told to put in 3 significant figures? And then you go, is my answer sensible? And if you think about it, okay, I had calculated round about 0.05 for my oxalic acid. I need twice as much sodium hydroxide from the equation. So I would expect my concentration to be more or less double. So 0.1 is more or less double 0.05. So it does look like a sensible answer. The reason why it's not exactly double is because we used 20 milliliters of acid and we only needed 16 to 17 milliliters of base. So obviously the base is more concentrated because I needed less of it. So it's those sort of questions or things you think about whenever you're trying to work out, is my answer sensible? Any questions so far? Right. Well, I hope that was helpful. And my apologies for we've gone on way longer than normal simply because I did want to get to this point and you did waste a few minutes. Well, I wasted your time with my computer crashing. So won't see you next week, but I'll see you the week after. And we'll be finishing this part and then starting also the second part of the assessment where we do the dilution. Right, so hopefully that was useful. Any questions? Otherwise, you're welcome to go.